So, good morning, everybody. Kiran, you wrote KCT, right? How was the KCT for you? Hello, am I audible? Okay. And video is also proper, right? Screen is visible for all? Okay. So, good morning, everybody. Today is the easiest topic in the entire physics, that is modern physics, because very few formulas are there, and apart from that you are not going to get any more questions also. So let's see what's there in this. Okay, it was easy, very good. Okay, I hope you score very good marks in it, and let's start with our chapter. Okay, so first of all, like modern physics is we are combining few chapters, that is dual nature of matter and radiation, then there is atoms, nuclei. These three chapters together I have combined in this for this chapter. Okay, in dual nature the first topic is photoelectric effect. What is happening in that? A photon comes and it transfers all its energy into an electron in an orbit, and it will kick the electron out. Okay, so when we conducted the experiment, we kept two electrodes, and in one electrode the light was falling, electrons from that were attracted to the next one, and similarly photoelectric current was observed. Okay, based on this Einstein's equation is there about photoelectrons. Before that, this is Planck's equation. Planck's equation, what he is saying, energy of a photon is equal to h nu. H is the Planck's constant, nu is the frequency of the photon, or since nu lambda is equal to c, we modified that equation by hc by lambda. Hc by lambda is energy. So one more thing you have to remember, hc by lambda equal to energy or kinetic energy for the photon. Why? Because it doesn't have it is not having potential energy, completely kinetic energy. This we can say equal to half mv square. Okay, and from energy, let's say if you divide it with the c, you should divide with the velocity, you should get momentum, right? So from this we are finding h by lambda equal to momentum of photon. Okay, remember this. H by lambda is momentum of photon. Now E photon energy, Planck's constant, value of Planck's constant 6.62 into 10 to the power minus 34 joule per second. C speed of light, lambda photon wavelength, nu photon frequency. Now intensity, what is intensity? Intensity is energy by unit area into time. Okay, energy by time is power, so power by area is also intensity. Let's say that n number of photons are falling, so what will be the intensity? N photons falling, so n h nu. Nu, when we are applying, it is already per second. Okay, so total energy is this, and from this we can say that intensity is equal to n by 4 pi r square, that is the area, into p. This n is equal to nh nu, like number of photons. Okay, and power is equal to h nu by t. Okay, energy per time is power, so power into number of photons divided by area, that you will get as intensity. Is there any doubt in this? Okay, let's move on to the next one. Next is Einstein's equation for photoelectric effect. Here we are determining the kinetic energy of emitted electron or photoelectron we call it. Kinetic energy, maximum kinetic energy is equal to h nu minus phi. Phi is what? Work function. Okay, work function of the material. Work function entirely depends on material. Okay, so that is the minimum energy required for the photon to emit. So from that we will get 5 equal to h nu naught. Okay, nu naught is threshold frequency. Threshold frequency. This will also be equal to hc by lambda naught. With respect to wavelength also we can say. And like threshold work, if you know like minimum energy required for electron like emission from the material, you can find work function. That is h into threshold frequency or hc by threshold lambda. Now hc, usually we find energy and everything in joules, right? That is the SI on it. But when it comes to this electrons and all, in this chapter we are mostly dealing it with in electron volts. So you should know this. HC is equal to 12,400 electron volt Armstrong. So HC by lambda, Armstrong will get cancelled. You will get actual value of energy in electron volts. Okay. Then another equation for kinetic energy is equal to E V naught. E is charge of electron, V naught is stopping potential. Okay. So these are the formulas that related to photoelectric effect. Do you have any doubt? Okay, I guess not, so we can move on. Next is a topic that you won't get that many questions from, but it's better that you know the topic. That is Compton effect. In Compton effect, what is happening is that, like in photoelectric, photon comes, it gives all the energy to electron and electron have the full energy, right? But here what is happening is that photon is colliding with electron, but it is not transferring all the energy. It is transferring only some amount of energy, and new photon is scattered in one way and electron is scattered in another direction. Okay, so scattering of electrons by photon is happening in Compton effect. So here initial wavelength was lambda, final wavelength is lambda dash. So how much shift is happening, how much change in lambda is happening, that's what they are saying. When energy is decreased, lambda will increase. That's why lambda dash minus lambda is coming. That formula is equal to h by m naught c 1 minus cos theta. This will be maximum when theta equal to pi. Okay. This is maximum when theta equal to pi, because it will become minus 1 plus 1 2. It will become delta lambda maximum will become 2h by m naught c. Okay, this is the maximum shift in wavelength that can happen. And h by mu naught m naught c is equal to what? 2.42 into 10 to the power 12 meter. Okay, so this value also is given. Do you have any doubt regarding this?
What is m naught?
M naught is the mass of electron. Okay, m naught is mass of electron. Is it clear?
Yes, ma'am.
Okay, then moving on. Like we can easily say that because photon does not have mass when it is moving. Next is de Broglie wavelength or matter wave. Okay, what does this mean? It is meaning that since we found that h by lambda is equal to momentum of photon. This formula we got from the first page, right? So de Broglie suggested that opposite might also true. So h by p, if you take for any particle, you should get wavelength of that particle. Okay, universe loves symmetry, which means if in photoelectric effect it is said that light is behaving as a particle. So when a wave can behave as a particle can also behave as a wave. In that manner he proposed this formula, and later it was confirmed by observing electron. We confirmed that matter does have wave properties. So based on that we got lambda equal to h by p or h by mv. So Planck's constant by momentum, we will get wavelength of that particle. Now p square by 2m is equal to kinetic energy. From this we are getting this formula, h by root of 2mk. M is mass of the particle, k kinetic energy of the particle. Now let's say that instead of giving kinetic energy, the question is saying a particle is accelerated through a potential. In that case, V is the potential, Q is the charge of particle. Then you can use this formula. Okay. If kinetic energy is not given and it is said that particle is accelerating through a potential, then you have to use this formula. So we have only one equation and modifying that to according to each case by case. That's what we are doing. Now for an electron, if you take this formula, we know charge of electron, we know mass of electron, and h is a constant value. So we can get a constant formula, that is 12.27 divided by root V Armstrong. You don't have to by heart this. If you are able to by heart, then it's a good thing. Even it's not, you are not able to, you have the formula, you can calculate it at that time. Okay. For a proton also we know charge, we know mass. Substituting, we will get this value. Then for neutron and alpha particle and neutron cannot be accelerated in a potential. So for a neutron, this formula is not valid, but this formula we can use. Energy of neutron and other values we are calculating to be a constant. Then for alpha particle, this formula is valid. Deuteron also, that formula is valid. Neutron does not have a charge, that's why this formula is not valid for that. Okay, is there any doubt in this? Okay, if not, let's move on. Next is we are starting getting into atoms chapter. So in atom, first Thomson model and all is there, but we are only getting numerical with Rutherford model and Bohr model. Okay, in Rutherford model you know about scattering experiment. So and based on that on the findings of Rutherford model, electron is orbiting the nucleus. So if it is moving in a circular orbit, it should have a centripetal force, right? So centripetal force is provided by what? Our electrostatic force. This is nothing but, if you are taking a hydrogen atom, 1 by 4 pi epsilon naught electron into proton, 1 proton. So E square divided by R square, radius of the orbit. This is for hydrogen. Now if you are taking a higher atom like helium or lithium, nucleus number of protons is increasing, right? So Z value is coming from that. What is the centripetal force on one electron due to nucleus? That's why Z is happening there. Okay. Next, if you want to find kinetic energy, sorry, not kinetic energy, for finding distance of closest approach. Distance of closest approach. Okay. And from Rutherford model and alpha particle scattering experiment, we have these two formulas. One is distance of closest approach, another one is impact parameter. Distance of closest approach means when an alpha particle is coming towards a gold atom, it is positive, alpha particle also positive, so it should repel, right? So what is the closest distance it can come? Near the gold atom. That is the thing. So kinetic energy of alpha particle, okay, this is of alpha particle equal to potential energy by the atom. Okay, gold, if it is gold, we have to use gold. Sometimes they might give another examples in the question. So use the potential energy due to that atom. Here nothing else will change. This Z will be what? Z will be atomic number of that particular atom we are using. And this X is our distance of closest approach. So X equal to this value we will get. Okay. Do you have any doubt regarding distance of closest approach? Okay. Next is impact parameter B. Impact parameter means if this is the nucleus, gold nucleus, and this is the line through the center. Okay, let's say our alpha particle is coming in this direction. By reaching here, it will deflect and go in this direction. This angle is theta. Okay, this distance is impact parameter B. Angle of deflection is theta. Distance between line of alpha particle to the center of nucleus, that distance is called as impact parameter. How we are finding it? Formula is 2z square cot theta by 2 divided by 4 pi epsilon naught m v naught square. Okay, this m v naught square we are getting from kinetic energy of alpha particle. Don't worry about that. See, most of the case you won't get any question based on impact parameter, but still there is 1% chance. More chances are for distance of closest approach. Okay, do you have any doubt in this? No. Okay, so let's move on. Next is classical atom model. Classical atom means we are basically applying Rutherford model, and we are applying Newton's laws with it. Okay, so force, this equation we already saw. Electrostatic force is equal to mv square by r. From this we will get velocity of the electron in the orbit, and substituting that we will get kinetic energy of electron, and based on that, from if you know kinetic energy, you can already find potential energy, because that potential energy is just k q1 q2 by r. From this equation you can find potential energy. After finding V, you can find kinetic energy. Substituting, you can find total energy of electron. That value is equal to minus E square by 8 pi epsilon naught r. So the drawback here is only if you know radius, you can find what is the total energy. Bohr model, we are overcoming that. We are substituting for r also, and we are able to find actual what is the value of energy. So this much we are getting from Rutherford model. Okay, substituting kinetic energy and potential energy. Is there any doubt? Okay, going to Bohr's atomic model. First of all, we have to know this equation, that is like angular momentum of an electron in the orbit will be equal to nh by 2 pi. N value will be 1, 2, 3, etc. That is principal quantum number. Okay, this is the first Bohr postulate. Then based on our previous example with Rutherford, same way we will apply here. Like at any orbit, what will be velocity? So from that equation and this equation combining, we will get equation for radius of nth orbit. If electron is in nth orbit, what will be its radius? So it is this formula, and only n square is the variable here. All other values are constants. So being that constant, we will get this value. What is that? That is the smallest orbit of electron when n equal to 1. A naught, or sometimes you can see it as r naught also. Both are same. Okay, smallest orbit of electron, and then substituting that in V. From here we are getting equation of V with respect to r, right? For that we will substitute the r value, and you will get equation for V also. Here also n is the only variable, so rest of the things, minimum velocity of electron in the orbit when n equal to 1, this is the value. Okay, and comparing these both, we can say that Rn proportional to n square and Vn proportional to 1 by n. Even if you don't by heart the whole equation, this you should know. Rn proportional to n square, Vn proportional to 1 by n. Or simply if you want to write, you can write Rn equal to A naught n square, Vn equal to V1 by n. Okay, so these are the formulas. Now we already had a total energy equation. We just substitute r value in here. So here also we will get n is the only constant. So En proportional to 1 by n square. So these three proportionality are very much important, okay. And the other values, when you substitute, you will get the value E naught equal to minus sign is like we are adding because of negative sign, minus 13.6 eV. Okay, E naught value, okay, minimum energy of electron in the first orbit. So this is the value, and En can be written as minus 13.6 divided by n square eV. So better to learn these equations. Instead of studying the formulas, you can learn these equations and the proportionality. Is that clear? Is there any doubt in this? Okay. Then moving on. Next one is atomic spectra. This is also a result of Bohr's atom model. Why? Because there are we are confining the radius of electrons, right? We are saying that it can only remain in some radius or some orbits. So when the electron gets energy from the photon, it is getting scattered. Let's say it is getting only small amount of energy, so it will scatter from one orbit to another orbit. It is going there, and since it makes the atom unstable, what will electron do? After a small amount of time, atom will come back to its original orbit. When it is coming back, it is emitting the initial energy it got. Okay, that energy it is emitting as a photon. So what will be the wavelength of the emitted photon? That is atomic spectra. Okay, basically what we are doing, electron gains energy and moves to a higher orbit, and when it is coming down to the original orbit, it emits a photon. What will be the wavelength of that photon? So this is the only formula for that, and based on this we have like divided into multiple spectra. You know the names: Lyman, Balmer, Paschen, okay, Brackett and Fund. These are the spectral series. Lyman series, like whichever higher orbit electron is going to, it is coming back to first orbit. Okay, electron went from first orbit to another, then it is coming back to first orbit. So here n1 will always be equal to 1. n2 can be from 2 to infinity. Similarly, Balmer series, n1 will always be 2, n2 will be 3 to infinity. Like that, n1 equal to 3, n1 equal to 4, n1 equal to 5. Like that we have divided the spectral series. In this, still the question will not be exactly by giving n1 and n2. They will say longest wavelength or maximum energy. These types of words will be used. So how to identify that? Maximum energy is from n1 to infinity. Okay, maximum energy means it is going from n1 to infinity. Next, maximum wavelength or longest wavelength. Okay, longest wavelength. Longest wavelength means minimum energy. Wavelength increases, energy decreases. So longest wavelength is from n1 to another level n1 plus 1. If it is saying lowest wavelength or minimum energy, it will be from n1 to n1 plus 1. If they are saying maximum energy or shortest wavelength, it is from n1 to infinity. Okay, do you have any doubt in that? Okay, I hope you understood this. And most of the cases RH you won't have to learn the values. Okay, and this is read by constant. Most of the time you don't have to learn the value. Either it will be given in the question, or it will be a case where it is getting cancelled out. Okay, moving on. Next we are coming to nucleus. Okay, so when we come to nucleus, we have to define this AMU and all. Why? Because inside nucleus there are only protons and electrons. Oh, sorry, protons and neutrons are present inside the nucleus. So what will be the mass of a nucleus? If we want to say, we will say in AMU, because if let's say there are 12 total 12 protons plus neutrons, we will say 12 AMU, like that. So 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. So you know it is approximately equal to mass of proton, approximately equal to mass of neutron. But mostly we cannot use mass like approximate value. We have to use exact values. It will be given in the question. Don't worry about that. And we have to use in electron volt. Okay, energy and all we have to calculate in electron volt. So better we have to convert 1 AMU equal to 931. You don't have to use 0.4. 931 might be okay. Mega electron volt by C square. Okay, this is the value of 1 AMU. Okay, now size of the nucleus, it is of the range of 10 to the power minus 15 meter. Minus 15 usually we write as Fermi or femto. Okay, femtometer or fermimeter. Its size range is 10 to the power minus 15. Size of an atom, size of atom is approximately 10 to the power minus 10 meter, Armstrong. Okay. Next, for size of the nucleus, radius of the nucleus, how we are finding? We have an equation, R equal to R naught, a constant value given here, into A to the power 1 by 3. What is A? A is the atomic number. Okay. Sorry, A is the mass number. Mass number. If you know mass number of a like atom, you can find the like size of its nucleus or radius of the nucleus. Do you have any doubt here? Anyone? Okay, then let's move on to the next topic, that is mass defect and binding energy. Okay, mass defect is coming from, like, when we are talking about a nucleus. For example, let's take helium nucleus. So there is one proton and one neutron. So total mass of the nucleus will be what? Mass of helium nucleus will be 1 mp plus mn, right? This should be mass of helium nucleus, but when we are weighing it, its value is coming less than that. Okay, it should be this mass, but its mass is coming less than that when we are observing it. So where is that extra, like, lost mass going? That lost mass is going into keeping this proton and neutron together. For example, we know proton doesn't attract neutron. Neutron is neutral charge, proton is positive charge. So why do they stay together? It is because of binding energy. That binding energy provided by that lost mass. Lost mass, how we are finding? So this is the actual value, ZMP, total number of protons plus total number of neutrons into mass of them, minus we are calculating mass of atom. So we have to minus the mass of electrons from it. If they are directly giving mass of nucleus, instead of this you can simply write mass of nucleus. Okay. Either if they are giving mass of atom, you have to write in this way. If they are giving mass of nucleus in the question, the whole term you can replace with m nucleus. And this is converted to binding energy by Einstein's equation mc square, delta m c square. Here why I told you we are using this 3931 mega electron volt. Instead of calculating it, if you get the value of delta m in AMU, you can easily multiply it with 931 mega electron volt and calculate the binding energy. Is that clear? Do you have any doubt in this? Anybody? Please respond. Okay. So moving on. Next is binding energy curve. So as you know, we are not talking about total binding energy. Total binding energy more doesn't mean that it is more stable atom or stable nucleus. Binding energy per nucleon should be more, then only it will be a stable atom. For example, let's say in your home there are 3 people. If only one person is earning 50,000 rupees. So if each of the, like for 3 people, 50 by 3 will be the expenditure, right? Now let's say in some other family there are 5 people. Only one person is having 50,000 salary. So it will be less than that. Like each person will get less expenditure than the first family. Because of that, so total energy is not what we are thinking about. Total energy per nucleon divided by number of nucleons, when we calculate, it should be more. Okay. So for here you can see that when now like mass number is less, the value will be small. Okay, because binding energy is small in this part. And when you come to the top, what is happening? It is stabilizing. Okay, it is getting to a stable value. And when you go into higher mass numbers, then what is happening? Like BE by A we are plotting, right? This here it is binding energy by A. So A increasing, again total value will decrease, right? That's why it is decreasing on this side. Initially binding energy is less, so the value will be less. Then it will increase and reach a stable value, and again it will decrease because A is increasing. And the maximum binding energy per nucleons is for iron. That's why we call it as strongest metal. Okay, iron. Now, is there any doubt in binding energy curve? I guess not. Moving on. Next is nuclear fission and nuclear fusion. So in nuclear fission and fusion, what is happening? Fission means there is a heavy mass nucleus. It will split into smaller nucleuses and become stable. As we can see in the previous one, here total binding energy per nucleon is less, which means it is less stable. So attaining stability, it have to become smaller nucleus. Okay, how it is doing? Like if we bombard it with a neutron, that extra energy will be spent into splitting into it. While happening, you only have to do one thing. Make sure before and after total mass number is same and total atomic number is same. Only that is required. Okay, you don't have to learn anything else. Before and after the process, total mass number and total atomic number should be equal. Same for fusion also. Fusion, lighter nucleus. We saw that lighter nuclei are also unstable. They will also combine together to form heavier nucleus and become stable. Here also you have to see only one thing, that is before and after mass number, atomic number same. Okay, apart from this, you need to know what is alpha particle, beta minus particle, beta plus particle, positron. Okay, alpha particle is helium nucleus. So this is He, mass number is 4, atomic number is 2. Helium nucleus, so it is positive. Beta minus is just electron. Beta plus is positron, and positron both are same. Beta minus means if alpha particle is emitted from a nucleus, actually 2 protons, 2 neutrons emitted from it. That's what alpha particle emission means. Beta minus emission means this is electron. Okay, so what is happening? A neutron is separating electron from it and it is converting into proton. This is beta minus, which means neutron is converting to proton. Number of nucleons remain same, but what happens? Number of protons will increase. In this case, if let's say X, A, Z was there, if alpha particle it is emitting, it will become Y, A minus 4, Z minus 2. If beta beta minus emission is happening from X, A, Z, what is happening? One neutron is converting to proton. So here mass number will remain same, but atomic number will be increased by 1. In positron emission, what is happening? Positron emission, or this also same, positron emission or beta plus, what is happening is that a proton is separating positron from it and converting into neutron. So here also no change in atomic number. Atomic number will remain same, but mass number will remain same. Atomic number will be reduced by 1. So these are radiations. Okay. Do you have any doubt? Okay. Then one more point I have to add, that is in Bohr atom model. Okay, we told this proportionality, right? This is for hydrogen atom where Z equal to 1. If you are thinking about hydrogen like atoms, okay, if you are thinking about hydrogen like atoms, then you like Rn is proportional to n square by Z. Okay, H like atoms. Now velocity is proportional to Z by n. So hydrogen like atoms is there, you have to use this. Next is energy. Energy proportional to Z square by n square. So better learn this, then you know that like Z equal to 1 in hydrogen atom, so it will, the proportionality stays still. Is it clear? If it's clear, we can move on to problem solving. Okay. De Broglie wavelength of an electron orbiting in n equal to 2 state of hydrogen atom is close to. See, Bohr radius, I told you it will be given in the question. We don't have to by heart. N equal to 2 state, we have to find what? De Broglie wavelength. To find De Broglie wavelength, how we can find? It is equal to h by p. So if you want to find p, that is equal to h by mv. Okay. Velocity in nth orbit we have to find. What is the formula? Anyone? Nobody is saying anything. See, n equal to 2 it is given, and what is given? R naught equal to 0.052 nanometer. This is also given, but for finding lambda we need velocity. So we should be able to connect what? These given things into velocity. Okay, so first find radius. Okay, radius of nth orbit is equal to n square r naught. Okay, n is given, so Rn is equal to 4 into 0.052 nanometer. So we will get V1 by n. Okay, that is good. But V1 value is not given. Okay, we are not expecting like that we should by heart the value. If you by heart it, it's fine. But if you haven't by hearted, what can we do? Okay, then for finding V, we can use
0.67.
what? Okay, answer.
Option D.
Okay, thank you. Very good. Okay, if you are not by hearted, you can use this value NH by 2 pi. Okay, then R we found from here. MV will be equal to what? NH by 2 pi R. R we found, N is 2, so 2H divided by 2 pi into 4 into 0.052. Okay, 2 cancel. When you substitute H will cancel, and you can find lambda equal to what? Pi into 4 0.052 into pi. This will be value of lambda. Okay, answer is option D, not option D. Actually, I think it's option A. Sorry, let's check. Sorry, option D is the correct answer. Okay, did you understand? If V is
Yes, ma'am.
okay, so the thing is, from the given things we have to find. Okay, maybe if you use the V1 by n equation here, maybe it will be correct. Sorry, maybe it will be correct, maybe it will be wrong. So from the given things, try to find. Okay, next is which of the following options represent variation of photoelectric current with property of light shown on the x-axis? So on the y-axis there is photoelectric current I, and x-axis there is intensity and frequency. Okay, which of this will correct? Now frequency gives the kinetic energy of electrons only. Because of if we increase the frequency, current is not going to change, only kinetic energy of electron will change. But intensity means, when we saw the formula, we saw number of photons. Yes, anything?
Option A.
Yes, option A is the correct answer. Okay, so intensity increases, number of photons increase. Number of photon increase, number of electrons emitted will increase, current will increase. Option A is the answer. Everybody understood? Okay, moving on. A photon and an electron have same energy E. Ratio of lambda of photon by lambda of electron of their de Broglie wavelength is. A photon and electron of mass m have same energy E. So from energy we know that energy of photon is equal to hc by lambda. So from this we will get lambda of photon is equal to what? hc by E. Okay, similarly from lambda of electron, how can we find? If energy of electron is given, we know that lambda of electron is equal to h by p, and if energy is given, it will be h by 2 me, root 2 me. Okay, so this is lambda of electron, this is lambda of photon. If you want to find lambda of photon by lambda of electron, it will be hc by E divided by h by root 2 me. What will be the answer? This is not E, sorry. It shouldn't look like E. That is C. Which will be the answer?
Option D.
Yes, option D. No, is it option D? Are you sure? See, when you cancel H, it will be C by E into root 2 ME. Okay, E and root E will cancel, so we will have C into root 2m by E. Okay, answer is option A. Is it clear? Are you guys solving?
Yes, ma'am.
Okay, moving on. Next, if phi is the work function of photosensitive material in electron volt and light of wavelength of numerical value lambda equal to hc by E meter is incident on it with energy above its threshold value at an instant, then the maximum kinetic energy of photon or electron ejected by it. Even though the question is so lengthy, it's very easy. Okay, lambda is given, phi is given. You have to find kinetic energy of photoelectron. These are the only things that we need to see. Okay, so kinetic energy of electron equal to energy of photon minus phi. Energy of photon, since lambda is given, we can use hc by lambda minus phi. Substituting the value of lambda, you will get phi equal to kinetic energy equal to E minus phi. Is that clear? Guys, do you have any doubt?
Yes. No, ma'am.
Okay, moving on. Next one, the graph which shows the variation of 1 by lambda square and its kinetic energy E, where lambda is the de Broglie wavelength of a free particle. So, kinetic energy E and 1 by lambda square. Okay, lambda is equal to what? H by root 2 m E. Okay, 1 by lambda will be 1 by lambda square will be 2me by h square. So, from this we can say that E is proportional to 1 by lambda square. If you write 1 by lambda square equal to x, so E proportional to or y, then E proportional to y. What is the graph of this? C. Are you sure? It is directly proportional. Okay, if you are thinking about 1 by lambda square with the lambda, okay, lambda versus E, it will be like this.
Any option A.
No. Lambda versus E, it will be like this. But already they are plotting 1 by lambda square here on the y. So, it will be E proportional to y. That E is x. So, x proportional to y. What graph is that? That is option D. Okay, straight line graph. This is what the confusion will be. Okay, they have already plotted 1 by lambda square. They are not asking lambda versus E. Lambda versus E will be this curve graph. But like since they have already plotted 1 by lambda square, you have to use this equation. Okay, I hope I am clear, and we can move on to the next question. Is anyone having? Okay, moving on. The work functions of cesium, potassium and sodium are 2.14, 2.3 and 2.75 respectively. If incident electromagnetic radiation has energy 2.2 electron volt, which of the photosensitive surface may emit photoelectrons? You don't need my help in this, you can directly answer. For not potassium. See, the radiation energy should be greater than work function. then only electron will be emitted. Cesium, yes, that is the answer. Like H nu should be greater than or equal to 5, then only electrons will be emitted. Here the H nu is equal to 2.2, so it should be, it is greater than only one value, 2.14, that is for cesium. So photocurrent only in cesium. Okay, is that clear? Okay, then we can move on. Next, an electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. So that is the keyword here, negligible work function. If m masses of photoelectron emitted from the surface of de Broglie wavelength has lambda d, then okay, so a photon is coming which having lambda as its wavelength. It is emitting electron from a photo material which is having very negligible phi, which means phi we can assume to be 0, and the electron is having lambda d. Okay, so lambda d of electron is equal to h by root 2 mass of electron into energy of electron. Okay, and energy of electron, how we are getting? Kinetic energy equal to h nu minus phi, right? Phi is approximately 0, it's negligible, so we can directly write energy of electron equal to h nu. Since we have to write in lambda, it can be written as hc by lambda. Substituting that, you will get h by root 2 me hc by root lambda. Now we got the formula, we have to square and find which will be the appropriate answer. So from this only we know lambda d square we have to square, so this one is not the answer. Okay, then lambda d square is equal to h square, option B. Okay, D, let's see.
B second.
Okay, B. Okay, okay, h square lambda by 2 me hc, h and square cancel, and lambda equal to lambda d square into 2 mec by h. This is the answer. Okay, so option D is the answer. Is that clear? Okay. Next one, light with an average flux of 20 watt per centimeter square. So what is power by area? Power by area intensity is given 20 watt per centimeter square. Falls on a non-reflecting surface at normal incidence having surface area. Some area is given, that is equal to 20 centimeter square. Energy received by the surface during the time span of 1 minute. Time is equal to 1 minute. So intensity, area, time given. If you want to find energy, energy equal to intensity into area into time. That's it. Time you have to convert to seconds. Here centimeter square, so it will cancel. That's why we don't have to convert that. So this will be equal to 20 into 20 into 60. Answer is yes. Yes, option B is the answer, correct. Okay, there is no doubt in this question, right? Can we move on? Okay. Next one, An electron of mass m with an initial velocity v equal to v naught I cap enters electric field E equal to minus E naught I cap at t equal to 0. Lambda naught is its de Broglie wavelength initially, then its de Broglie wavelength at time t is. So here we have to combine two knowledge, one is from modern physics, one is from electrostatics. Okay, initial velocity is given v naught I cap. Okay, so lambda is equal to h by m v naught. So we can find initial lambda, that is lambda naught, this value. Okay, then next we have to find after time t, it entered the electric field, right? If minus E naught is the electric field, then force acting on it will be equal to minus E naught into minus E, because electron is equal to force. Okay, so this is equal to F equal to ma equal to E naught E. So this will be plus I cap then, and acceleration will be equal to E naught E divided by m, mass of electron. Now we can use this after time t. New velocity will be equal to v naught plus at I cap, right? V naught plus at I cap, and new wavelength will be equal to h divided by m into v. Substitute a in this, then substitute v here. Do you have the answer? We will have h divided by m into v naught plus e naught by mt. If you take v naught outside, you will get lambda naught divided by 1 plus e naught t divided by mv. Answer is option A, v naught. Is it clear for everybody? Am I audible? Okay. Then we can move on to the next question. When the light of frequency 2 nu naught is incident on a metal plate, maximum velocity of electrons is v1. Frequency of incident radiation increased to 5 nu naught, maximum velocity is v2. Ratio of v1 to v2. Maximum velocity we can find using kinetic energy maximum equal to half mv max square. Okay, so half m v1 square is equal to, and threshold frequency is nu naught, which means phi equal to h nu naught. Okay, so here it will be h nu minus h nu naught, which will be equal to what? H nu naught. Okay, 2 nu naught minus nu naught. In case of second one, half m v2 square is equal to h nu minus h nu naught again, but here it is 5 h nu naught minus h nu naught equal to 4 h nu naught. From this we have to find v1 and v2, then find ratio. Can you do that?
Option B.
Option B, yes. Are you sure? Because we don't have to directly find it. We have to find v1 and v2. From v1 is equal to 2h nu naught divided by m under root. Then v2 equal to 2 into 4 h nu naught by m. When you take the ratio v1 by v2, you will get 2h nu naught by m will get cancelled. 1 by root 4, that is equal to 2. Option A is the answer. Is it clear? Okay. Then we can move on to the next one. De Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T and mass m. Okay. Now, like this is given, like temperature is given. Based on that, we have to find. So, if with the, like when we convert thermodynamics, we saw that if temperature is given, we can find its energy, kinetic energy equal to 3 by 2 kT. Okay, and our equation for de Broglie wavelength is equal to h by root 2m E. Substitute this E here, you will get the answer. Answer is option A, h by root 3 mkt. Okay. This is from equipartition theorem. Moving on. A particle of mass m is moving around the origin with a constant force F, pulling it towards the origin. If Bohr model is used to describe its motion, radius of nth orbit and particle speed v in orbit depend on n as. Okay, so from here we get mv square by r equal to force F, right? And Bohr model is used, which means mvr is equal to nh by 2 pi. Okay, then sorry, don't go into that. Pulling towards the origin, F equal to mv square by r, and from this F is constant force, so mv square equal to F into r proportional to v square. This we will get. Next we are substituting mvr equal to nh by 2 pi. Okay, this is from Bohr model. And since r proportional to v square, this we can write as mv cube equal to nh by 2 pi, which means v proportional to n to the power 1 by 3. Okay, so that option there is A in A and C. Now we have to find r proportional to v square. So when we square this, you will get r proportional to n to the power 2 by 3. Okay, option A is the answer. Do you have any doubt in this? I think not, so let's move on. Next one. Some energy levels of a molecule are shown in the figure with their wavelengths of transition. Then, like out of this, which will be true? That is the question. So, transition and wavelengths are given. Minus 2e to minus 4e. So, here delta E is equal to delta E3 is equal to minus 2e. Okay. Next one, delta 2 from minus 2 to minus 3. So, delta E2 is equal to minus 1e, right? Next is from minus e by 2 to 4e. There delta E1 is equal to minus minus 5 by 2 plus 4E. What will be difference? 8 minus 5 minus 3 by 2 E. Okay. Actually this will be 4 minus 5 by 2E. Okay, like this it will come. So minus 3 by 2E. And we have these values of energy, and delta E is equal to Hc by lambda. From this we are getting the equation, which one? In Bohr model we are getting atomic spectra equation, right? That is from this. Delta E should be given by photon emitted, which means delta E by Hc equal to 1 by lambda, and that gives us lambda equal to Hc by delta E. Okay, so delta E is more, lambda will be less. Delta E less, lambda will be more. So which is the highest one? Comparing to this, we can get that lambda 2 equal to 2 lambda 3. Okay, so from that only we can get either these two. Now lambda 1 or lambda 2, which is greater? From comparing to this, we can get that lambda 1 is greater, right? Sorry, lambda 1 energy is more, which means lambda 1 is less. So option D is the answer. We are finding delta E first, then comparing it with this to find lambda. Okay, is it clear? Why are you guys not responding? Are you guys not understanding? Okay, then we can move on. Sorry. Given below are two statements. Statement 1. Atoms are electrically neutral as they contain equal number of positive and negative charges. So, equal number of positive negative charges are there in one atom. So, it is neutral. That is true. Next one. Atoms of each element are stable and they emit their characteristic spectrum. When they are stable, will they emit spectrum? No. As I told you, electron absorbs energy, go to a higher level and becomes unstable. Then it will come down to the original state and emit emit photon. So when they are stable, they do not emit any spectrum. So this is false, which means answer is option C. Statement 1 is correct, but statement 2 is incorrect. Okay, is that clear for everyone? Okay, then let's move on to the next question. Next one, in list 1 there are given some transition from N1 and N2. Then list 2 wavelength they have given. Okay, wavelength is inversely proportional to energy. So maximum energy, minimum wavelength. In this, maximum energy will be from 2 to 6, right? All others are like less than that. Maximum energy 2 to 6. So D will be having least wavelength. Least wavelength is 1. So D to 1. That we will connect. D to 1, only one option is there. So without calculation you can get the answer. Understood? See, if you have time you can calculate each and every one. But in NEET we don't have that time. So we have to use like quick steps. So here we are seeing maximum energy, minimum wavelength, connect it. If again it is having two options like that, then go to the minimum energy, maximum wavelength. That also you connect, you will get the answer. Okay, here minimum energy will be from 2 to 3. Okay, 2 to 3 will be from minimum energy. It will have maximum wavelength, that is 3. So A to 3. See, A to 3. Like that you can get the answer. Is it clear for you guys? Okay, so I hope you guys understood this. We are connecting minimum wavelength to maximum energy and maximum wavelength to minimum energy. Okay, in that way we are connecting and we are getting the answer. Option B. Okay. Can we move on to the next question? Okay, let's see. Next one, a like reaction is given, like disintegration. So what is happening? We have to find the mass number and atomic number of final product Q. Okay, so how we are doing that? Initially X is having 29082. So from X 29082, alpha particle is emitted and becomes Y. When it becomes Y, I told you when alpha particle is gone, mass number reduced by 4. So 290 minus 4, 286, and atomic number reduced by 2. So this becomes 80. Next is it is having positron emission. Positron emission is same as beta plus, as I told you. So what is happening? A proton is converting into neutron. So 80 will become minus 1, mass number will not change. This will be 286, this will be 80 minus 1, that is equal to 89. Okay. Next what is happening? Again beta minus is happening. Beta minus means electron is being ejected. Sorry, this is not Y, Z. Okay. Beta minus happens and it will become P. So beta minus means neutron is being converted to proton and emitting electron. So this will become constant only, nu 86. This will increase. Sorry, 79 here. Okay, 79. This will become again 80. Proton number is increased. Finally, one more electron is emitted, that is like beta minus only. So from P 286 and 80, again electron is emitted. So a neutron is converting into proton. So this will become, there is no change in mass number, but this will become 81. This will be answer, 286 and 81, option D. This is how you find this one. Okay, is it clear? Okay, moving on. When a uranium isotope 23592 is bombarded with a neutron, it generates krypton and 3 neutrons. So as I told you, we only have to balance before and after. Before 23592 plus 1 neutron. Neutron 0 atomic number, 1 mass number. So 236 is total atomic mass and atomic number is 92. This is converted into krypton, that is 8936 plus 3 neutrons. So neutron 3, 0. As you add here, this side 89 plus some x. Okay, here it should be 236 minus 89 plus 3. Okay, mass number should, yes. Okay, similarly, are you sure option C? Let's see. Okay, next mass number should be like whatever their value, 92 minus here only 36. Then what the answer you will get, that will be the answer. Okay, as you can see, 2, B and C are having 36. You only have to confirm what will be A. I hope your answer is correct. Okay, no, sorry. See, total mass number and atomic number should be equal, right? So X should have, see, 89 plus 3 plus, let's say this value is equal to Y, plus Y should be equal to 235. Okay, and similarly 92, here it is 36, this 36 plus another value Z should be equal to 92 both side. So that's why we are writing it like this. So here Y will become 89 plus 3, that is equal to 92. So 236 minus 92. Okay, 6 minus 2 4, and 23 minus 9 14, 144. With that only you will get answer D. Okay, only one option is there. Is that clear? Okay, moving on. If an electron in a hydrogen atom jumps from the third orbit and to the second orbit, it emits a photon of wavelength lambda. When it jumps from fourth orbit to third orbit, the corresponding wavelength of photon will be. Okay, so from 3 to 2 when it is emitting, wavelength is lambda, which means 1 by lambda is equal to R into 1 by 2 square minus 1 by 3 square. Okay, so from this we will get R into 9 minus 4 divided by 36. Okay, and we will get R is equal to what? R is equal to 36 by 5 lambda. Next we have to see from 4 to 3. So 1 by lambda dash is equal to R into 1 by 9 minus 1 by 16, 1 by 3 square minus 1 by 4 square. R we already got as this, so 36 by 5 lambda into 16 minus 9 divided by 16 into 9. 16 minus 9 you will get 7. So this is equal to 7 into 36 divided by 5 into 16 into 9. 16 and 36 we can say 9 and 4, 9 9 cancel, so 7 lambda also here. Okay, 7 by 20 lambda. So answer is lambda dash equal to 20 by 7 lambda. Option C. Did you understand this? This is why I told you we don't have to learn the value of R. We can easily, without knowing the value also, we can calculate. Is it clear for all? Okay, moving on. When an alpha particle of mass m moving with the velocity v bombards on a heavy nucleus of charge Ze, distance of closest approach from the nucleus depends on ms. Our equation is coming from half mv square equal to potential energy on this side, that is k z e square into 2 divided by r square. This is sorry, not square, r. Okay, so this is how we are getting the formula. Yes, option C. So when we put r this side, it will proportional to 1 by m. Okay, I hope that's clear. Can we move on to the next one? Last question for today. That is, given the value of Rydberg constant is 10 to the power 7, wave number of last line of Balmer series of hydrogen spectrum will be. Wave number we have to find 1 by lambda, because usually k is equal to 2 pi by lambda. If pi value, like you have to substitute and find. Otherwise 1 by lambda is fine because 2 pi is constant. 1 by lambda equal to r into last line of Balmer series. Last line will be like Balmer n1 equal to 2. So 2 to 3, 2 to 4, last line will be 2 to infinity. So 1 by 4 minus 1 by infinity. This is 0. So r by 4. 1 by 4 is equal to 0.25 into r is 10 to the power 7. So answer is option A. Okay. Is that clear? Okay. Then and that's it for today's class. Please practice more questions from these chapters because it is very easy. There are not much other difficult questions from this. I hope that's it. Please join back to chemistry class at 12 o'clock. Till then you can take rest. You can leave the call.